Hi guys, we are going to be today doing Module 1, Lesson 8. So keep in mind if you have not done lessons before Lesson 8, so 7, 6, 5, 4, 3, 2, or 1, just make sure you are going back and checking Seesaw or Student View to find those old links. They're all on YouTube, but you have to be able to go to the right place to find them. So make sure you have watched all of those before you watch this one. Okay, for Lesson 8, our objective, or what I want you to be able to do by the end of the lesson, is to demonstrate the commutativity of multiplication and practice related facts by skip counting objects in array models. Okay, so I want everyone focusing on that word, commutativity. So in yesterday's lesson in Lesson 7, we talked about the commutative property. Okay, and we're going to go back over that before we get into our lesson too far. Okay, but first, we're just going to warm up our brains by doing some skip counting. So what we're going to do is we're going to count by 2s to 20. So we're going to whisper the numbers and then speak them. Okay, so for example, I'm going to say 1, 2, 3, 4. Okay, and I want you saying it with me or thinking it in your head. So we're going to count by 2s to 20, whispering and then saying the numbers. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. Okay, very good job. So this time we're going to hum the first number, then speak the next number. So as you hum, just like we whispered the last time, I want you thinking of that number. This is just a way to practice that skip counting. Okay, here we go. Do it with me. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so that hum just replaced the numbers that we said. So this time, instead of humming, I just want you to think that number. And some of us, if you need to, you can pause and just think it. Take that time to count that number in your head and then say the next number. Here we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so we're going to keep moving on, but anytime if you need help counting by a certain number, practice it that way by whispering the numbers first, then humming them, and then eventually you'll be able to just think them in your head. So very good job with that. All right, so this is going back over what we talked about yesterday, the commutative property. So on this array you see right here, how many groups of 2 do you see? How many groups or rows of 2 are there? I see 1, 2, 3. Okay, there are 3 rows of 2. So I'm just noticing that this was a little mistake here. So this should be the number 3. How weird. Okay, so there are 3 rows of 2. So that would be represented by the multiplication problem 3 times 2. Okay, but let's think back to what we did yesterday when we turned our arrays to show a different picture. So if we were to turn this array right here, if we turned it on its side, it would look something like this. Okay, do we still have 3 rows of 2? No, now we have 2 rows of 3. So as a multiplication problem, that would be written 2 times 3. Okay, so yesterday we talked about the commutative property, and that is this right here. That is saying that 3 times 2 is equal to or the same as 2 times 3. It's just saying that they mean the same thing, even though the pictures look different and the numbers are in a different order. Okay, so this is going to kind of continue to talk about that. So it says children sit in 2 rows of 9 on the carpet for math time. Aaron says we make 2 equal groups. Vitesh says we make 9 equal groups. Who is correct? Explain how you know using models, numbers, and words. Okay, so let's take a second to break that down. So let's look at this picture right here. Looking here, we see Aaron's array. So Aaron said we make 2 equal groups. Okay, so she's thinking that they have 2 groups of 9, or 2 times 9. Vitesh says we make 9 equal groups. Okay, so here are his groups. So 9 equal groups of 2. So his problem would be 9 times 2. Okay, are either of them incorrect? No, like it says here, both of them are correct. It just depends on how you are looking at the array. Because if you turned either of them on their sides, they'd look like the other person's. So they were just looking at it differently. Okay, and the problem, so there's the same number of students. In both of these situations, there are how many students? 18. They were just looked at a little bit differently. So that's the commutative property. It's saying that 2 times 9 is the same as 9 times 2. And remember from yesterday, these two numbers that we multiply together are called factors. So all we did here was just switch the factors around, but it means the same thing. All right, so we're going to talk a little bit more about that today. All right, so what I want you to do is I want you to skip count by 3s 4 times and write each number. So let's go ahead and do that now. So we're going to skip count by 3s 4 times. So we have 3, 6, 9, 12. Okay, so that's 1, 2, 3, 4 times that we skip counted by 3s. So now we need to draw an array to match our skip count where the number of rows represents the number of groups. All right, so let's go ahead and draw our array. So I know that I have 3 in each group. Oops. Let's go back here. So I have 3 in each group, and I have 4 groups total, or rows. So I'm going to start by drawing 1 row of 3, 2 rows of 3, 3 rows of 3, and 4 rows of 3. Okay, and if I wanted to move my skip count over here, I can just write my skip count right next to each row. Okay, so let's talk about what we see here. So how many rows and columns do you see? That's a new word, rows and columns. So remember, rows go side to side like this. Columns are going to go up and down. Okay, so we have 1, 2, 3 rows. Okay, and we have, well, actually, no, we have 1, 2, 3, 4 rows, and we have 1, 2, 3 columns. Okay, So we have 4 rows, 3 columns. Okay, so if we were to turn our array, then how many rows and columns would we see? Okay, so let's talk about that. So we had 4 rows and 3 columns, but if we turned our array, it would look like this. So let's see, let me draw it up here. So if we turned our array, it would look something like this. Now, if this is our new array, do we still have 4 rows? No. This time we have 1, 2, 3 rows. And do we still have 3 columns? No, this time we have 1, 2, 3, 4 columns. So when we turn our array, what happens? So what is the difference? Did the total number of dots change? No, because if I did my skip count here, I would do 4, 8, 12. So no, the number of dots didn't change between the arrays. Okay? So nothing changed. The total and the factor stayed the same, but the factors switch places. So just like yesterday, that's the commutative property. So if we were to write these 2 arrays as multiplication sentences, we would write for this one, we would take 4 times 3. And that would represent 4 rows of, because remember that multiplication symbol can also mean rows or groups of. Okay, so 4 rows of 3 is equal to, and for our other array, we would have 3 rows of 4. So according to the commutative property, 4 times 3 is equal to the same thing as 3 rows of 4, or 3 times 4. They both equal 12. Okay, I'm going to stop here and move on to part 2. So go ahead and go back to Seesaw, and you should see a link to click on to watch video number 2. Great job following along and listening.